what you're asked to show here is, given some point P, any point P, normal through P intersects with the axis at Q. Here's the focus. And we want to prove this ratio, this distance here. Okay? Which is interesting. This is very close to the locus definition of the ellipse. But it's not quite, because it's actually to do with a different point. Anyway, so how are we going to go about this? What I've found with most of the conics questions, particularly for the ellipse and the hyperbola, is that algebra-wise, things can go bad very quickly if you don't pick the right approach. Okay? Whereas if you do, it just kind of falls out. And then when someone shows you the answer, you're like, why was I going round and round in circles? And almost certainly the reason you were going round and round in circles is because it's because of your approach. Right? It's like, I used parametrics when I shouldn't have. Or I just was trying to find the wrong distance first, and so when I was trying to find the other distance, it was very unclear what I was trying to simplify toward, that kind of thing. Okay? So just before we actually put pen to paper, have a think about how you might approach this. What's going to make this easiest for you? Now keep in mind you've got the focus there, right? And the coordinates of the focus are AE naught. Okay? So you've got that as something which is kind of a firm point, and you're not going to be changing that. There's no other useful way to express the focus. Now, when you've got that in place, that gives you a bit of a clue as to how you might want to express P. Because of course you could just say it's any point, x1, y1, right? And that would work fine probably. But being that this is already in terms of A and E, right? It's in your interest to use the parametric expression for the coordinates of this point. Can you see why? You see why? Because rather than saying x1, y1, which could be anything, right? If I call this, what are the coordinates? A cos theta, B sine theta, okay? You see you've already got two things in terms of A, right? So things are going to have to cancel out here when you're going from Q to S and then from P to S. Should have put that in as well, I suppose. Okay, so those are the two distances that I'm interested in, right? Now, another quick question. Clearly I'm going to have to work out what QS and PS are. Which do you think is easier to work out first? Now, just think about it for a second. If I were to work out QS, first I would need to know where Q is, right? Now, thankfully, since it's on the axis, it's just something 0, right? Just like the focus is, yes? But I don't know what the something is just yet, right? And if I were to work out the something, I'd need that equation PQ, wouldn't I? And then I'd have to substitute it in, and then I would get a value. Now, once I have that value, it's trivial to get that distance QS because it's just a horizontal distance, that's fine. But I don't know what Q is yet, right? So that gives me an extra step before I can work out QS. On the other hand, PS, I already know where P is and where S is, so I can actually work out that distance right away, okay? So I think it's in my interest to work that out, and then when I go toward QS, I'll have an idea of what I'm simplifying toward, because I'm going to have to show their that ratio is true. So they should be very, very close to each other, the expressions, okay? So does that make sense? You see how I'm trying to plot out what direction I'm going to go in, so my algebra ends up easier for me later on. So let's work out PS, shall we? Okay, it's just distance formula, right? So what are you going to get? Square root of A cos theta minus AE all squared plus, and because it's a 0 there, it's just going to be B squared sine squared, right? Okay, now have a look at that. What kinds of things are going to be useful to you here? You've got this Pythagorean identity thing happening here, right? So it's probably going to be useful to get as much of this together and squared as I can. Okay? So let me express this I'll square it out and see what happens. A squared cos squared. What have I got here? I've got 2a squared e cos plus a squared e squared plus this. Is that okay? Yes? Now have a look at that with me. You need some help before you get any further in your simplification of this, right? You've got A's and E's and B's, but you guys know for any of these conic sections that A's and E's and B's are somewhat interchangeable because they're all related, right? Do you remember what's the equation that relates all of them? X intercept A and B. Should be b squared equals a squared outside of? Good. And of course, if you were doing a hyperbola and not an ellipse, the difference would be that these are switched around. Okay. All right. Now the question is, let me just expand that out. A squared minus a squared e squared. The question is, how do you want to use this, right? You can see you've got an a squared e squared here. You've got a b squared there, a squared there. Which might be the most useful for you? I think I probably want to get rid of this, right? It's the quickest way to get rid of something. I mean, I could make a squared e squared the subject, right? And then replace this. But then you're making it worse, not better. I want to eliminate variables out, okay? So if I take this here, this is what I'm going to substitute in, right? I'll get square root of, it's a long one, a squared cos squared, 2a squared e cos, a squared e squared, all right, here we go. A squared sine squared minus a squared e squared sine squared. Okay? Now, even though it's like, I'm so sick of saying squared, right? That's actually a good thing for you, right? Because all of this, we're going to take the square root, right? And if I can get everything in terms of something squared, then that'll be really nice. I can get rid of the square root. What can I do? What can I do here? What kind of options do I have? Okay, so I can see a cos squared and a sine squared here, right? So they're actually just going to become a squared, aren't they, right? So I can do that. Let's see here. Drag this a squared e squared out the front. What have I got here? Minus 2a squared e cos. I've accounted for this, I've accounted for this. And I'll say plus a squared. And then I've got this guy. Didn't need so much after all. Okay, can I do anything else here? I can take out a factor of a squared, I can take out a factor of a squared here, can't I? So that gives me, let's see, a squared outside of e squared minus 2e cos theta plus 1 minus e squared sine squared. There we go. How does that look? What else can I do here? Remember, I'm trying to eliminate things out, trying to get things in terms of the same variables as much as I can, right? This sine squared here, surely I can do something with this, right? It's easier to do something with this than to do something with this, because it's squared already, right? So what could I replace it with? I could replace it with 1 minus cos, right? So I've got my a squared out here. E squared minus 2e cos theta plus 1 minus e squared, okay, 1 minus cos squared. Yes? Okay, what's going to happen here? You've got a minus e squared here and an e squared here, right? Yeah, I keep telling you, colors really help, right? So they're going to cancel out. That's nice. There, right? Then I'll have a minus e squared minus cos squared, so that's going to be plus e squared cos squared, right? Okay, so I've got a squared outside of, what did I just say? E squared cos squared minus 2e cos theta plus 1. Okay, and now that should make you look very suspicious, right? What can I do with this? This is a square, isn't it? This is a square here. So this is the square root of a squared e cos theta minus 1, because of that minus sign, right? Minus 1, all squared. Is that okay? That's not bad, hey? Right? So can I write this? I can almost write that, can't I? It's not quite. It's not quite. When you take the square root of some square number, right? What's it going to be at the end? Well, it has to be, can it be negative alpha? Let me graph this thing, the square root, right? Looks like this. Can it be negative? No, it can't, right? We actually define the square root that cert as the positive value. It's just plus alpha. In fact, this here is one of the definitions for the absolute value of alpha, if you remember that. Okay? So this is actually this, which you might think, oh, it's a bit of a pain, but actually will be useful to us later on. Okay. So now I have an expression for PS. Okay. So I'm going to keep that in the back of my head, right? When I'm working toward getting QS, it's going to be in my interest to simplify it, not just any random direction. You know how at this point we're thinking, what should I get rid of, right? I now know exactly what I need to get rid of when I'm working toward QS, right? I ought to get, now what I'm required to prove, is that QS is E times this. I want to get to this. And I'm sure there are other ways to express that distance QS, but this is the particular one I'm interested in. Does that make sense? Okay, so that's what I'm trying to get at. Can I rub this off, or do people still want it? Okay. Okay, now if you came late, let me just see if I can rehearse what's going on in my head as I'm going through this. Okay, my first step was step 1, and you might even like to do this for yourself because it'll give you an idea of where you're going, and so you don't get lost in the algebra. The first thing was work out distance PS. Okay, that was the first thing we did. Now I need to work toward this. So what's my intermediate steps between that, right? Well, I'm going to have to work out what equation PQ is, right? So I'm going to have to do that. Once I've got equation PQ, what am I going to do with it? What am I working toward? I've got to find where Q is, don't I, right? So that'll be step 3, locate Q. Okay, and the very last thing I can do with that is work out the distance QS, and then I should be home. Okay. Distance. What did I say? Yes. Okay. Now, do you need to write that? Of course you don't need to write that. Okay. But does it help you not get lost in the algebra? It really does. Okay. So eventually you'll get to the point where you'll be comfortable enough with these conics questions where you can sort of have that lodged in your head. But until then, just write it out so you know where you're going, and you're not like, why? What's my square root doing? Why am I doing this? Which one am I choosing? Now you know where you're headed, right? Okay, what's the equation PQ? What's the quickest way to get there? We do know the point that it's going through, right? So all I really need to know is the gradient through it, right? Now what's the gradient at P? The gradient at P, what's it equal to? For an ellipse. Be back. This is a result you need to learn. You need to really learn it. I'll give you a tip. It's a fraction. And it's negative. Does it remember? Should be B cos on A sine. Does that ring a bell? Yes? Okay. Now we don't actually want the gradient at P, do we? We want the gradient perpendicular to P. So we want the gradient of the normal at P. Okay, which is just a matter of flipping, get rid of the minus sign, right? Like so. Yeah, okay. So now surely I can work out PQ. PQ, I know the point that it goes through, so there's y minus y1 equals m, this, times x minus x1. Okay. Now, I could just leave it there, right? But I want to work toward getting Q, right? So what form should I put this in? How should I simplify it? What would you do? Which intercept am I after? I'm after the x-intercept, aren't I? Right? So I'd probably put this, probably the most useful form, x-axis, right? Woohoo! It's too early today. I think the form I got it before was this. I just kind of want the x out on its own, so I just multiplied through and I simplified out some of my fractions. So I should end up with this. Takes a bit of getting there, but I think you've actually done equations of normals and tangents sort of to death. So hopefully you'll be able to get from here to here all right, okay? Now, I've done this, so now I need to do this. How do I go about doing that? You let y equal 0, right? So for coordinates of q, okay, so what are we going to get here? Oh, that's right. It just disappears. Okay, now stop for a second. Remember, the whole reason we went for working out PS first, which I just helpfully rubbed off, didn't I? I should have said that. PS is equal to, what do we say? Absolute value of a, what is it? E cos theta minus 1. There you go. Okay. Now, if that's what I'm working toward, and this is what I have here, right? I can do better than this, can't I? I don't want b's in there, yeah? So I can replace that with something else, yes? What could I replace it with? I can replace it with a squared minus a squared e squared, right? Minus this. Whoops, sorry. Is that okay? But you can see the a squareds just cancel. So that gives you this. Okay, what did I want? I wanted x, didn't I? Right? So I can cancel out an a there. So x should equal a e squared cos theta. That's promising, isn't it? Think about what I have to get toward. Okay. So if that's what belongs here in that blank, I didn't really leave myself enough space, did I? A e squared cos theta. 0. Yeah? Okay. So remember I said before, it should be trivial to get that distance qs, right? How do I work out qs now that I know the coordinate? Now be careful, right? I think our instinct is to say, look, AE is bigger than this, right? So I would say AE minus AE squared cos theta, okay? So you're like, okay, hold on. So that's, what's that? I take out a factor of AE, which gives you this, right? And you get 1 there, and then you get E cos theta there. Now, is that what you were expecting? Is it what you were expecting? You're like, what went wrong? It's very close, isn't it? The E is where you want it to be, because it's E times the whole thing, okay? But this thing is backwards, right? Why is it backwards? Now, at this point, you might be tempted to think, I need it to be E cos theta minus 1. So I guess on this line, I'll just turn it around, and I'll subtract the smaller one from the bigger one. Except that should make you unsettled, right? Because you're like, I'm after a distance here, right? I'm after bigger minus smaller. What's the problem? You guys know diagrams can be helpful, right? 99% of the time they're helpful. But sometimes they lead you in the wrong direction, okay? Because at the moment I've drawn P such that its normal goes through there, so Q ends up on the left of S. That point ends up on the left of the focus. But it doesn't have to be there, does it? Because P can be anywhere we like, right? For instance, if I put P, I don't know, somewhere like here, right? So where would its normal go through? It'll hit something like that. So now Q will be over here, right? So actually Q can be anywhere you like. You can't just say it's this one minus that one. You have to have a little more finesse than that, right? So in fact, this here should really be this, to account for the fact that it could be on either side, right? Distance is what you get from absolute value. Just like in complex numbers, you take the modulus, it gives you the distance. Okay? So that's that. Now, how does that change things? Because I'm taking the absolute value of this, right? I can actually multiply the inside by -1, and it's fine, because eventually I'll take the absolute value. This is the same as this. AE cos theta minus 1. See that? I mean, just to give you a simple example, the absolute value of 5 minus 2 is still the absolute value of 2 minus 5. Because all I care about is the absolute value, the distance between them, right? So that's why you're like, that seems like magic. You can just flip things around because you want to. No, it's not. It's what happens if you understand absolute value. And that's equal to E times PS. So there's your proof, okay?